Okay, welcome to classwork homework number 14. And today we're talking about special right triangles, in particular 30, 60, 90 triangles. So this is day 2 of special right triangles. In the previous lesson, we talked about 45, 45, 90 triangles. And now we're going to find some patterns or shortcuts for 30, 60, 90 triangles. So we're going to start by seeing where 30, 60, 90 triangles come from to help you understand what these shortcuts are. So the first thing we need to do is to draw an equilateral triangle ABC, and we want each side to be 2 units long. ABC. Okay, so I'm going to mark this side as being 2, this side as being 2. I'll put a little mark right here, and then down here as being 2. Okay, so my equilateral triangle ABC with each side being 2 units long. So I'm done with that one. The first question it's asking me is, what is the measure of each acute angle? If we have an equilateral triangle, all the sides are equal and all of the angles are equal. So that means that all of the angles have to be the same. All of the angles have to be 180 divided by 3, which is 60. So we can label all of these angles 60 here. Okay, next it says, I'll label that right here, 60 degrees. For part B, it says draw AD, which is a perpendicular bisector to BC. So I'm going to draw this perpendicular bisector. I'm going to drop a line down from A all the way down to BC. And it says that this is a perpendicular, which means it's going to be making 90-degree angles with BC. And it's bisecting BC. So if it's bisecting the length BC, then that means each of these two sides will be equal. And if these two sides are equal, then we know what those lengths are going to be. They're each going to be 1 unit long apiece because the whole side length was 1. So we drew the perpendicular bisector to BC. What is the length of BD and CD? That would be 1 unit long. Part C is asking us, what does AD do to angle A? So if I look up here, if I drop this perpendicular bisector, not only is it bisecting the side BC, it's bisecting the angle. So this would be 30 degrees and 30 degrees. We're just going to break that 60 in half. So it says, what is the measure of angle BAD and CAD? Each of those angles would be 30 degrees because that angle is bisecting. Or I'm sorry, the perpendicular bisector is bisecting that angle. The last part is asking us to find the length of AD. And it says to leave your answer in simplified as a simplified radical. So I'm going to look at the left here, and I see I have a triangle A, B, and then this right here, I didn't label my D right here. So I can find this missing side AD by using Pythagorean theorem. So that's going to be 1 squared plus, we don't know what that's going to be, I'll say it's B. B squared is equal to 2 squared, which is the hypotenuse. So solving, I get 1 plus B squared is equal to 2 squared is 4. Subtract 1 from both sides. B squared equals 3. And the square root of both sides, then B is equal to square root of 3. Or in other words, AD is equal to the square root of 3. So let me go ahead and label that into the picture here. So I want you to focus in on this side of the triangle right here. I have side length 2, I have side length 1, and then I have this length right here as being rad 3. So when I look at this triangle is a 30, 60, 90 triangle. I have a right angle right here. And this pattern is going to come up time and time again anytime you have a 30, 60, 90 triangle. And that is that one side will be half of the other, and the other side will be rad 3 times the other one. So if you take a look at this side right here, side length of 1, well, to get the hypotenuse, we will just multiply by 2. And to get this other side length right here, we multiply by rad 3. So this is going to be a trick that works every single time, no matter what the side lengths are. So let's kind of make some conclusions here about the things that we just talked about. It says, conclusion, we have created two 30, 60, 90 triangles within one equilateral triangle. The side lengths of that 30, 60, 90 triangle in order from least to greatest were 1, rad 3, and 2, where 1 was a leg, rad 3 was a second leg, and then 2 was our hypotenuse. So it says the ratio will always hold true for any 30, 60, 90 right triangle. So we don't have to use the Pythagorean theorem moving forward because we can use these shortcuts. So let's go through and define a couple things about 30, 60, 90 triangles and what exactly that shortcut is. So in a 30, 60, 90 triangle, so you have three angles. You have 30-degree angle right here. You have a 60-degree angle and a 90-degree angle. So we need to be specific about what the sides are here. So the side that is opposite 30 degrees, which is the side over here, is one of the legs of the right triangle, but we need to differentiate this. Oops. Whoa. Let's undo that. So this is one of the legs of the right triangle, but we need to tell this apart between the other leg of the triangle. So we're going to call this the short leg. This will always be the short leg because it is opposite the 30-degree angle, and 30 degrees is less than 60 degrees. So if I want to label the other side here, the side that's across from 60 is another leg, but again, we want to be specific about which leg this is. This is called the long leg. This is the long leg because 60 degrees is greater than 30. So because of that, this side will be longer, and we call this the long leg. And then the last side here is the side that you already know. The side that is opposite the 90-degree angle will always be the hypotenuse. Okay, so if we start by identifying the short leg, I'm gonna use some abbreviations here. This is the short leg, which is always across from the 30-degree angle. The side opposite 60 will be the long leg, and then the side opposite the 90-degree angle will always be the hypotenuse. So let's say that our side value for the short leg is x. Okay, the relationship between the short leg and the hypotenuse is that you would multiply the short leg by 2 to get the value of the hypotenuse. So this would be 2 times x. Okay, the relationship between the short leg and the long leg is that if I take the short leg and multiply by the square root of 3, then the long leg is going to be x times rad 3. Okay, so these are our two relationships. Let me write this out in the form of a formula, if that works better for you. So the hypotenuse is equal to the short leg times 2, and the long leg is equal to the short leg times rad 3. So 2 things to note here. There's only a relationship between the short leg and hypotenuse and the short leg and long leg. Notice there's no relationship between the long leg and hypotenuse. So you always are going to have to go back to the short leg if you want to find either the hypotenuse or long leg. The second thing that you need to know is that if you want to go in the reverse direction, if you want to go back this way, if I give you the hypotenuse, then you would want to divide by 2 to get the short leg. And if I wanted to go in the reverse direction here, then I would want to divide by rad 3 to find that leg. So let's go ahead and try 2 different examples to see how this will work out. Example 1, it says find the value of x and y. So the first thing I want to do in this picture is I want to make sure I know what each side is, which one is the short leg, which one is the long leg, and which one is the hypotenuse. So I see 30 degrees is labeled here. The side opposite that is 6. So the short leg is 6. X will be the hypotenuse. So I'm just going to label H over here. And then Y would be the long leg, because that's going to be opposite the 60-degree angle. We can write that in right here. Okay, so now that I know the short leg, well, if I want to find the hypotenuse, all I have to do is hypotenuse is equal to short leg times 2, which is equal to 6 times 2, which is 12. So X is equal to 12. Okay, now to solve for the long leg, which is Y, I have to go back to the short leg, and the short leg multiplied by rad 3 will give me what I'm looking for. So if I want to solve for the long leg in formula layout style here, the long leg is going to be equal to the short leg times rad 3. So that's going to be equal to 6 times rad 3, which is just 6 rad 3. And it is that simple. So Y is equal to 6 rad 3, and X is equal to 12. So when you are given the short leg, your computation should be very straightforward. You only have to multiply by 2, multiply by rad 3. Let's try a different example. It says find the values of X and Y. Let's go through and label all of our sides. So X would be the short leg. It looks like Y would be the hypotenuse, and this side with 12 on it would be the long leg. So I am given the long leg currently, so I'm going to have to take the value for the long leg and work backwards to find out what the short leg is. Then once I find that, I can multiply by whatever I need to multiply by to get this hypotenuse. So what this means is I have to, if I want to write this out again in, as an equation here, I have long leg is always equal to the short leg times rad 3. So if I fill in my information here, I have 12 is equal to short leg times rad 3. So we want to solve for the short leg, which means we have to divide both sides by rad 3. By rad 3. Which means the short leg is equal to 12 over rad 3, and of course we can't leave it like this. So we'll multiply by rad 3 on top and bottom. We'll get 12 rad 3 over 3. Taking a look at 12 divided by 3, we'll get 4 rad 3. So X, which is the short leg, is equal to 4 rad 3. So we had quite a few more calculations here than we did on the last problem because we weren't given the short leg. We had to divide by rad 3 to find the short leg. So now that I have found the short leg, I can go ahead and figure out what my hypotenuse is going to be. And the relationship between the short leg and the hypotenuse is that we multiply by 2. So if I write this out, hypotenuse is equal to short leg times 2. So that would be 4 rad 3 times 2. Remember, multiply the free 4 and the 2 together. You'll get 8. So the hypotenuse is, which is Y, is going to be 8 rad 3. So this is the most complicated question that you will get, is when you have a number given for the long leg and you have to find the short leg and then multiply to find your hypotenuse. Good luck with the rest of this lesson. Leave comments, questions, and like the video.